So, Bismillahirrahmanirrahim. Mrs. Subia Suhail is here. Assalamu alaikum, my dear students. Last time I have explained about the second order derivation, okay? And in the second order derivative, sometime if we are getting the proofs like this one, x is equal to sine theta, y is equal to sine m theta, then there is a proof that we have to prove. In this one, it is a second derivative. This one is the first derivative. Okay, second derivative, first derivative, it means from this one you have to find out dy by dx, that will be counted as first derivative, and then dy1 by dx, that will be counted as the second derivative. First you have to find out this and this. Now how to find out this? Because the question is involving the theta, it means you will take the help of the chain rule. When we have a parameter used in the question, then we have to apply the chain rule to find out the value of dy by dx. Okay, look at this one, dx, it will be differentiated with respect to theta. dy, y, it will be differentiated with respect to theta. Okay, so dy by dx, if theta is involved over here, it will be dy by dx, and d theta will be here. This will be the required chain rule for this type of the question. Okay, so let me continue this one, naming this as equation number 1. Take the question now. Explanation is done. Now take the question. X is equal to sine of theta, so dx by d theta you can do. Yeah, with respect to theta you can take the differentiation. Sine d by d theta of sine of theta. What is the derivative of sine? Cos of the same angles, then angle derivative. As d theta by d theta will be considered as 1, so it is equals to cos of theta. Yeah, you can name this as equation number 2. Now the derivative of y. Okay, y is equal to sine of m theta, sine of m theta. So dy by d theta, it will be equals to d by d theta of same function. Okay, derivative of sine is cos of exactly the same angle, and then derivative of angle is m theta. Okay, so when we are writing it like this, cos of m theta, m is a constant number, so we can write it as it is, and the theta derivative will be 1. So we can write it as m cos of m theta also, or we can keep it as it is also. Now if we are writing the chain rule, we know that our chain rule was, when we are involving theta, dy by d theta into d theta by dx. Very good. Dy by d theta means this one. Okay, that is cos of m theta into m. D theta by dx, reciprocal of dx by d theta, that is 1 over sine of cos of theta. It's okay. It will stay as it is until you need to change back into that one, dy by dx. We can write it as y1 cos of m theta. M I can write in the start over cos of theta. Okay, now before taking the derivative of y1, can we think about that we can change the cosine ratio in terms of the sine again? Wait. Yes. Cos of square theta, we know that it's equal to 1 minus sine of square theta. And we know in this question x is equal to sine of theta. Yes, we can use it. So cos of square theta equal to 1 minus x square. We want only cos theta, so we can take square root on both sides. So square root this cancel. Okay, so this value cos of theta can be replaced by 1 minus x square over here in this one. Okay, so this one will be equals to y1 equals to m cos of m theta over 1 minus x square root. Now shift this over here. 1 minus x square into y1 equals to m cos of m theta. Now only this theta is left. Because y1, if we are differentiating, numerator also have theta, denominator also have theta, so we are applying the quotient rule also. Even then it's getting very lengthy. So we just replace one value with respect to x. Now we will do this differentiation with respect to x. So x is involved over here. Here x was not involved. Totally the whole formation was in terms of theta. Now x is involved here. So it's better if we are doing the differentiation now. Differentiate. Yeah, differentiate with respect to x. Now we are differentiating with respect to x, not theta. Okay, so keep that in the mind. This is the first function, second function. First function as it is, derivative with respect to x of the second function plus y1 derivative of the second function, first function. Okay, equals to m is a constant number, derivative of this function with respect to x. Okay, now 1 minus x square staying as it is, its derivative will become y2. Okay, plus y1 as it is, its derivative, power rule will be applied. So I can make a big bracket, power in start, 1 minus x square power minus 1, and derivative of the function without power, 1 minus x square. Okay, here derivative of cos is minus sign. So sine of same angle, minus I'm writing in the start. And then derivative of the angle. Okay. Now this become 1 minus x square y2 plus y1 bracket 1 by 2, 1 minus x square power become negative half. Okay, and its derivative is minus 2x, because minus sign, x square derivative, power in start, power minus 1, so it become minus 2x equals, this minus is there, m is there. Can I replace this sine theta with the question value as it is given as? Yeah, so can I write y here? Okay, and then this also, again the derivative of m theta will be equals to m constant number, and d theta by dx will be as it is. We have to replace the value of d theta by dx over here. Is that okay? 1 minus x square into y2 plus this 2 into cancel, and y1, this will be minus x only in the numerator, and this denominator, can I shift it down? 1 minus x square and whole positive under root. Okay, or positive square root power minus m square y. What is d theta by dx? 1 over cos theta. Okay, so instead of cos theta, again I can write its value the same, 1 minus x square. Yeah, so I will continue in the next. Be careful when you are shifting the page. 1 minus x square, then y2 plus minus 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 this minus xy1 over this in the square root form, minus x y1 over square root of 1 minus x square excuse me, equals minus m square y divided by, can I write the value of cos theta that we find out over here? 1 minus x square, 1 minus x square square root. Now whether we can make the denominator same at the both side or multiply this on the other side, whatever you want to do, you can do it. I can say the denominator is here 1, so I can take the denominator common, 1 minus x square. In this case, when there is 1, so whole denominator is multiplying to the numerator, so it will become 1 minus x square square y2 minus, means the simple solution is that if this one is here, so multiply this to above numerator. Okay, This is just a small trick. Minus xy1 equals to minus m square y over 1 minus x square over there. Now across the equality, corresponding elements exactly with the same sign can be cancelled as it is. Okay, so I will cancel this one. Remaining is left 1 minus x square. Square and square root cancel each other. Y2 minus xy1 equals to minus m square y. We have to make a proof form. So in the proof form, this was brought in the start. So I will bring this term in the start in this side, 1 minus x square y2 minus xy plus this was xy1. Thank you. Equals 0. So this is our required formation to achieve. Required formation. Okay, sometime it is being given that find out the y1, okay, first derivative, sometime y2, okay, second derivative, but sometime if it is given that find out the required formation or prove like this or show like this, then we have to attain the required formation in that question, in that specific part. Okay, and that's so easy also. I like these type of the question because you're sure about the formation, that once you achieve that requirement or once you go to that formation, it means your full working is correct. If you're not coming to that formation, it means there is a mistake in your working, so check out your working again. Okay, so in this one, that is completely done, and then we start the next part. But until then, I think, thank you so much. In this part, this one is enough, so don't forget to subscribe my channel. Allah Hafiz.